And what are you going to spend it on? Well, it's a straight line. I've got $100 to spend. I can buy all gas. I can buy all gasoline or somewhere in between. What's the slope?
Marginally substitution.
What's
That's the
for the budget constraint? But you're right on the indifference curve.
It's
Nope, that's what the indifference curve is.
it's the price difference.
It's a price ratio. Yeah, the price ratio, the relative price. What goes on top? Price of this over the price of that.
Price of the Y.
Which one? The y-axis, horizontal axis, right? Which is the change in all other goods, but it's always backwards. So you can, however you've memorized that, hopefully you've got it memorized. But the price of gas over the price of all other goods. If you're ever wondering why, it's dollars per unit of gas over dollars per units of all other goods. Solve this, flip it over, and you've got change in the units of all other goods over the changes in units in gallons of gas. All right, so that's the slope, is the price ratio. So when we tax gasoline, what happens to the budget constraint?
Numerator
Goes down. All right. So we get this rotation out, and that is the substitution effect. If we break down with indifference curves, it doesn't make us as happy as we were before. If we didn't consume any gas, we don't give a rip, right? So we can still be up at this this part of the budget line. Gotta go.
Do you want this?
Yeah.
Want me to keep it?
No, why don't you let it go? All right, so there's that part of the equation. Now, with part B, so purchase 500, the tax will decrease Petra's gasoline because of the price increase. So if we think about a demand curve, as long as Petra didn't have some weird preferences, we can use the utility function to derive the demand for gasoline. Effectively, an increase in price causes less, right? A decrease, yep, from 5. So we were at 500. Whatever that mechanism is, whether it's a tax or whether it's a price increase or something else, the law of demand tells us we're going to reduce down to Q2. Okay, so law of demand. But that plays in from this picture. These two are linked to each other. All right, so good on B?
Yeah, it makes.
Does that help a little?
It changed, yeah.
All right, so use the consumer choice model to illustrate your answer to B. Oh, okay, so I guess we kind of rolled it into C. All right, anything else there?
I had a question on one, and it was on 6 on B. I think that all the calculations wrong on the answer sheet.
On which one?
6B.
Are we done with 5?
6B.
Oh, sorry. I thought that was
Did you have anything else on 5?
Yeah, I had a question.
Okay, yep.
Oh, never mind. Okay,
Good?
yeah.
Okay. So 6, back to you, Chelsea, what was it?
B.
6B.
I think they calculated part of their elasticity wrong.
Okay.
Because it's the percent change in demand over the percent change in price, right?
Just standard elasticity?
Yeah, elasticity of demand.
Yep.
Okay, so they did, 0.2 over 0.4,
And one of them's negative?
yeah, the bottom one was negative change in price.
Okay.
But the change went from 3 to 2,
Oh.
which would be, and they did it as if it was going from 2 to 3.
Oh,
And
okay.
so how they got 0.4. The negative's right, but I think it would be 0.33, not 0.4.
All right, so yeah, this could be one little technicality on how they did it. So you're talking about the change in price. I don't have it right in front of me, but so we went from $3 to $2, and so
It's new minus old divided by the old.
Right, right. So if we get the 3 minus 2 over 3, oops. Yeah. Let's do that a little bit different. New number is 2. 2 minus 3 divided by the old, or is it, and they're going the other direction, is 3 minus 2 over 2. Okay. And that was for here?
They have,
Is that where you got your 0.4?
0.40 over 0.20. That's their. They got negative 0.4.
All right.
have my answer sheet.
So,
Or no, it was 0.2 over -0.5.
Yeah.
And that gave you -0.4.
Or, there you go.
0.2,
For the change in quantity needed.
okay,
And then the change in price, they have 0.5, a -0.5.
0.5.
Which would be if they used that.
And you're saying it should be
0.33.
0.33. Okay. What is 1 divided by 2.5? We got a calculator out? 0.4. So, this is kind of the common thing to overcome that change. We did this in principles class, but it's the arc elasticity method. So instead of taking the new number or the old number, which isn't fair depending on if you're going with a price increase or price decrease, you take the average of the two.
But if it's for sure decreased, then why would
Because we want the elasticity to go, and I would, on a test problem or something, I will tell you this because different textbooks might not necessarily do this, but I like thinking of it this way. So let's just make sure we're all clear on what's going on. So we went from 3 to 2, and we don't have actually the quantities, but it doesn't really matter, right?
Yeah, it was 1,200 down to 1,000, or 1,000, that was 1,200.
Okay, 1,000, 1,200. So you remember how we talked about the elasticity of demand changing along a linear demand curve? Where it's unitary elastic. What was the upper portion? Elastic or inelastic? Elastic. Lower portion was inelastic because of the way these ratios change. If we're talking about a very low quantity, then it would be a big percentage change in price, but a small percentage change in quantity. If we're on this section of the demand curve, it's vice versa. So that was that whole story we went through there. And so to accommodate that, we did this formula. New minus old divided by the average. Divided by new price minus old price, just like you were doing, but let's divide by the average price instead. And so when we look at the elasticity, we kind of are saying the elasticity of demand right here is 0.4. Because otherwise, if you estimate it here or estimate it here, you'll get a different answer using that new or the old. When we get real sophisticated, we start doing a derivative, which would be basically a point estimate. There's another formula that ties back to the point estimate method that we used in intermediate class, where we had the point on the curve. So anyway, there's a couple of different ways. So that is what they did with this problem. And still didn't come out? What's that?
Because that, okay, so that would make it 1,200 minus 1,000 over 1,100, right, on the top.
Yeah.
And then 2 minus 3 over 2.5.
Right. No, not 2. 2 minus 3, yeah, 1. 1 over 2.5.
Yeah. And that gives you like -0.45.
So the 1,200 one doesn't map out with what they said either?
I don't know. On the answer sheet, they did it the new minus the old divided by the new. And they just had it wrong answer.
Oh, okay. So maybe they just screwed up. I guess, like I said, I'll be explicit if I would ask you a question
You
like
want
this
us to
on
do the
there.
average on the bottom.
This is probably the better way to do it, yeah, for these purposes. A lot of times we'll just give you the percentage changes and then we don't have to worry about it. at this point, I might even give you the formula because this isn't principles class anymore. If you need to, I'll tell you how you need to calculate it basically. So what does this equal though? What's the number? 200 divided by 1100?
0.18 repeating, so.
Oh, okay. And that doesn't match up what they gave. That's what you're saying, right? Okay.
They might
I don't see where you get the.
It's that. It's 1,000.
2200.
It went from 1,000 to 1,200. Did you derive that, or was that given to you?
I thought I went from. I guess it is the average.
The existing bridge has a free flow capacity of 600 vehicles, private trip cost, 2 volume. Given the bridge volume of 1,000 vehicles, the proposed replacement bridge has a free flow capacity of 1,200. So yeah.
So you have to say it's at 1,200 now. And we're back. So you. Are you doing? I thought I was just gonna have those.
So it, during.
You have the difference over the. I thought it was the difference over the old number, not the difference over the.
That's what we've been debating the whole time. So it sounds like the answer key once again screwed it. They weren't consistent.
It was wrong either way.
Yeah, they did one way.
Either way.
That's the one thing you don't want to do is do it different ways for each one.
Either way
So
it was wrong.
yeah, either way it was wrong. Okay.
If you did new minus old over old for the change in
Right.
price.
Sounds like it works one way,
over
but
two.
not for both.
Yeah, I was gonna say you got 1 over 2, so you got negative 0.5.
Okay. Anything else?
So the answer is negative 0.4, they just calculated it wrong.
Yes. And again, with these homeworks, you guys, I'm not so, we don't have to sit here. I don't mind beating up the answer key a little bit, but it's more important that you understand the underlying thing going on. So that
Why would it not be negative 0.45?
negative 0.45.
No, if you do the average. Okay.
If you put this number
Yeah.
divided by, the other. So 0.45.
Yeah.
All right, so there's your revised answer. Maybe I'll write that on my little
Wait, so do we have to do the average way or can we do the other way? 'Cause
As long as you were consistent, I didn't care.
Okay.
You're not going to lose any points.
Works.
And like I said, on a test, I'll do it a little bit differently. All right, let's get into some crime. How does that sound? So, economists treat all human beings, including criminals, as rational.
Are we done going over the homework?
Yes,
If we have any more questions?
I'll talk to you. All right, so let's see here. So again, this is chapter 13, an introduction into crime. Boy, what class is this?
Economics.
Yeah, we did a little bit of that with the Freakonomics stuff, didn't we?